Okay, let's see. All right, hey everyone, this is going to be a talk about the new Cairo version, Cairo 1.0. We're going to outline some differences between the old Cairo, give some security considerations, and also introduce our new open source tool. So who am I? My name is Justin. I'm a security engineer here at Trail of Bits. I'm interested in probably what everyone else is interested in, DeFi, blockchain, zero knowledge proof, obviously interested in Cairo and Starknet as well. Who is Trail of Bits? Well, we help secure some of the world's most targeted organizations. To do this, we also build a lot of open source tools. You might have heard of them, like Slither, Medusa, Solstice Select. And yeah, if you're interested, you can give anyone on the blockchain team a follow with the QR code. So let's jump right into it. I'm going to give some background about Cairo first. So what is Cairo? If you haven't heard of it, Cairo is a programming knowledge for zero knowledge proofs. And basically, that's just where a prover wants to convince a verifier that some computation was done correctly. And because of this, it has a bunch of unique features like hints, which basically means that the prover, the guy who's trying to convince the verifier, can put arbitrary input in the memory. And the memory model is also unique. You can think of it as being immutable. Once you write to a memory cell, that memory cell can never be changed. And so Cairo runs on the Starknet blockchain. So what is Starknet? It's a ZK rollup that helps to scale Ethereum, and you basically deploy Cairo code there, and then periodically, every so often, what will happen is batches of transactions will be, a proof will be generated, and it'll be submitted to the Ethereum L1 verifier. So now that we've introduced that, let's talk about the old Cairo version, or Cairo 0.x. Here's a small example that you can see of something called the Fibonacci sequence, which most of you have heard about. TLDR, it kind of sucks. Like, you have to write to every memory cell manually. There are no loops, so you kind of have to implement everything with recursion. And basically, there's no types, so everything is this thing called a field element, which is a felt 252. You don't have like UN 256 or anything. And also, another caveat is you have weird integer division. So in Cairo, there's this invariant x divided by y times y always equals x. That will always hold, so you don't have truncated integer division, and that's why you have really weird situations where something like 30 divided by 9 is this huge number, because in modular arithmetic, the invariant x times y equals, or x divided by y times y will always hold. So now that we've outlined the hell that is Cairo 0.x, let's move on to Cairo 1.0. And the TLDR is basically, now you're just writing Rust. So the memory model is completely abstracted away. If you remember, we had to write to the memory cell directly. We did AP, like AP equals something, AP++. None of that anymore, which is super, super nice probably for every developer. Also, we don't need to update any pointers, and we have nothing like tempvar or alloc locals, which is probably one of the best like improvements in DevX in a long time. So also we have types. So Cairo, since it's like Rust, is strongly typed. There's no more everything's a felt. You have things like UN 256, UN 128, usize, etc. One caveat that I'd like to mention is the native felt type is still there, but it's not overflow safe. The other types like UN 256 are. Also, we have like abstract data types like enums, generics, and we have traits, which is actually like what the contract implementations use. So here's an example of how you would write Cairo in, Cairo 1.0 or the Fibonacci sequence. It's just literally Rust, so not much more to there. We have things like pattern matching. We don't have to implement the call trait. It's basically a lot simpler and a lot better to write. So how do we actually do these things while respecting the memory model? Because we need to still generate like a ZK proof, right? That's done entirely through the Sierra IR. So the Sierra IR basically consists of it's the intermediate representation. So previously, we would compile directly from the low-level Cairo language directly to this thing called Cairo assembly. Now we actually go through an intermediate step, hence the name intermediate representation. So we go from Cairo to the Sierra IR to Cairo assembly. And this actually allows us to simplify the memory model. And one of the best things about the Sierra IR is this thing called a linear type system. So I'm not going to get too into it, but the linear type system basically allows us to ensure that every object is used once and only once, and it also uses like the Rust memory model, so basically there's no invalid references or dereferences. The Sierra IR basically consists of type generations or type declarations, as you'll see, and then these things called libfuncs. Libfuncs are basically the functions that are actually used in Sierra IR, so I'll give you some examples of them later. But the cool thing about libfuncs is they generate Rust code that's correct by construction. So when you use a libfunc in the Sierra IR, you'll always know that the Cairo assembly generated will be valid. Another core difference between Cairo, the old Cairo, Cairo 0.x, and Cairo 1.0 is gas metering. So previously, we couldn't charge for any failed transactions because if you had a statement in Cairo that was that led to like assert false, for example, it would lead to a sequence of constraints that are unsatisfiable, and then we can't actually generate a ZK proof for it. Because we can't generate a ZK proof for it, there's no way for the sequencer to include it in a block. So basically, the sequencer would do free work, and this is problematic because then you could just DOS the sequencer by spamming a whole bunch of transactions that had unsatisfiable constraints. But now what we would do is we basically would calculate the gas for every operation, and we have this withdraw gas and branch align lib funcs that kind of just syncs everything out. Another thing that is not mentioned in the slides is that every single Sierra code will basically generate branches. So let's say you have something like assert false. What would happen is in the previous Cairo version, it would just lead to a strict revert and you couldn't include it in a block. Now the Sierra code will generate a branch. It'll propagate the error back to the main VM entry point, and then the sequencer will basically be able to charge. So this is pretty big because we prevent a really huge DOS opportunity. So with all of these three things combined, we basically allow for a pretty flawless dev experience where you can, just write Rust, like I'm sure most of you have been writing, but we still have the same low-level guarantees of the memory and respect the memory model that Cairo does. So here's a small example of a Cairo program, and I'm just gonna briefly go over the Sierra representation. We have the type declarations, we have each of those lib funcs, and then we have their actual what the lib funcs do. I'm not going to go into depth too much because of time, but if you see, you'll actually notice that on the right-hand side, once we reuse an operand, on the left-hand side as an input, we won't ever reuse that that ID again, and that's the linear type system. So now that we've explored what the IR does, there's a very important question to ask, and that's, is security solved? Well, let's look at this particular curious Cairo contract that may or may not have a bug in it. Well, the answer is it does, and even if you have type safety and some memory guarantees, you don't have logic errors. So to do that, to help developers find bugs in their code, we open sourced this tool called Caracal, which is our static analysis tool. And if you run Caracal on the previous contract I just showed you, well, it'll point out that there's a reentrancy in it. So Caracal is built on top of the Sierra IR. We have we use some very common static analysis techniques like data flow analysis and taint analysis. Also, we have 7 detectors so far, so each of these detectors basically point out a common Cairo vulnerability and will flag it. Obviously, since we use static analysis, it's somewhat conservative, so we do recommend that you go triage every single finding from Caracal and use it in the same way that you would use Slither. Another core thing about Caracal is if you use Scarb, it's really easy to use with the Scarb directory. You literally just would use it in the same way that you'd run Slither or something on a Foundry project, so the dev experience is pretty good. We also have 2 printers, so we have a printer for the CFG, the control flow graph, and we also have a printer for the function call graph, and that might be really useful for just basically visualizing how your contracts actually interact and how the functions flow to one another. So, are there any questions? I'm sorry? Yeah, sure. So as you can see, this is actually, if you look at the detector, we call this reentrancy benign because we don't actually read the variable before, but we do write to it after. So we have 3 reentrancy detectors. There's 1 reentrancy, which is, you read from an external variable, you do an external function call, and then you write to the variable. So that's a pure reentrancy. This is reentrancy benign because what we do is we don't read from the variable, but then we write to it directly after. And there's 1 reentrancy for events, which is that if there's an external call, it may just make the events out of order.
Are there any bugs that Solidity is susceptible to that Cairo is not?
That's a good question, actually. I think the model is a lot different. There are a lot of bugs with just the way the EVM works. For example, there are a lot of vulnerabilities that are common, just logic vulnerabilities, for example, reentrancy. I think since Solidity has a different model, specifically in Yule, for example, there's a lot of bugs with checking return. I think there's a talk before about checking return data size, those kinds of things. Cairo, now that there were a lot of different bugs before in the old version because we had things for example, the weird division that developers may not expect. But now we more or less have the same kind of logic vulnerabilities, and it's not the same. I guess it's instead of having Solidity vulnerabilities, it's more business logic vulnerabilities rather than logic in the programming language itself, if that makes sense.
Hello. Is there a playground or sandbox for New Cairo?
I think there is the Cairo playground, like for 1.0, but for running Caracal, I think you just run it on your repo specifically. We don't have like any sort of sandbox for Caracal specifically, but for Cairo 1.0, there should be a playground on the Starknet like website. There will also be a remix plugin soon for your playground.
Okay. Thank you everyone for everything. And